All right, so today we're going to be going over data wrangling with the pipe. So we just talked about a lot of those tidyverse functions with dplyr, like mutate, transmute, filter, select, etc. So we did those as just you say one object or you do one function to it. The pipe is something that allows you to do things in sequence. And it looks like this. It's a percent greater than percent sign. To do the quick keynote for it, for a Mac, it's Command Shift M, and for PC Windows, it's Control Shift M. If you want to easily put that in, otherwise, it's just percent greater than percent, and you can type that out. So this week, we're going to incorporate the use of the pipe with other dplyr functions from the second week, the intro to data wrangling. So if this was coming directly after last week's tutorial, this would be before we continue learning some of the functions like group by and summarize together. You need to really know what the pipe is. So again, this pipe is a percent greater than percent. And it used to only be in the tidyverse. It is now in base R as well. And I think it looks like a bar. So like a bar with a greater than sign. So I think that's what it looks like in base R. I've never used that pipe before. I can put that in here and share that, make sure that's shareable. So it used to only be in the tidyverse that you could use the pipe, and now you can do it for other things. I don't know how compatible it is with a lot of base R functions or if that's improving. That's something that you can look into if you are interested in this. What's nice about the pipe is you to have basically it reads as text when you're using these tidyverse functions. Like we said, filter this, sort this, or arrange this, mutate this, etc. That pipe is just extending those lines of code saying filter this first, then select these columns, then group by year, species, then make a summary of things like length or weight or something based on those groupings. So it tells R to do multiple things in sequence. You can also pipe directly into other tidyverse functions like ggplot. So you can do a bunch of like data summaries, pipe directly into ggplot to visualize your data. But you just have to change to a plus sign because that's what ggplot uses. And we're going to be doing that later in this course as well. So we're going to first do an example of the pipe when using group by with summarize. So at the end of last class, we looked at summarize, and it basically just gave us like one value, which we could easily figure out from like using the actual function like mean or standard deviation or anything. But with group by, you can quickly calculate the means by any factor or more complicated analysis too. So we're going to load the tidyverse package here, and then we're going to read in this fish data set. I believe this is some folder data here. This extra information again just means for our weight column, bring it in as a numeric, or the tidyverse it's called a double. Because otherwise it's read in as a character because it has NAs in it. All right, so what we didn't learn before is group by. Group by is a very helpful function when you're using things that you want to group by a factor. So it allows you to group your data on some sort of factor here. By itself, as just like one function, it's not going to do actually anything except just group your factors. So I wouldn't use it as just the only function. It really needs to be used in sequence with the pipe. So here we're taking our fish data set, and if we remember what that looks like, it's a ton of different variables. including date, time, habitat, a bunch of electrofishing data, longitude, latitude, some depth, temperature, conductivity, current, and then information on the species, length, and weight of those species. This is the long-term resource monitoring element program in the Mississippi River. So it's just fish data from there. So what we want to do with this data set is we want to calculate the average length as well as the minimum maximum length of the different species. And we can easily do that by using the pipe with a group by and summarize. So if we want to look at our different species, that's called column species here. So what group by does is it's just the function group by, and then you just put in your columns there that you want to group by. So we just want to group by species. We're just putting species in there. Followed by the pipe, percent greater than percent. So what's interesting with the pipe is that you don't have to specify your data set name in every single function. Like we don't have it in the group by function. We don't have it in the summarize function like we did when we were just using one function in last week. You can specify your data set up front. So it's saying, look in this fish data set, pipe from this fish data set. So within this fish data set, group by species, similar to the attach function, if we remember that. Group by species, then summarize. And remember, summarize is the name of that variable you want to create. So mean TL, or for mean total length. And here we're just doing a rounding of the mean. So we don't have a ton of decimal places. We're only giving it 2 decimal places. That's what that digits means. So we're rounding the mean of the length variable because it's called length in this data set. Comma here. Our second variable we are summarizing is minimum total length. So min TL equals min of the length, comma, max TL equals max of length. So if you're calculating multiple summaries, just have a comma in between those summaries. And no pipe at the end because the pipe means continue doing more analysis or more data wrangling. So we just have the 2 pipes here in between our functions. We're naming this object fish group. So we're creating a new object. And this extra set of parentheses around the whole chunk of code means output our fish group object at the end rather than click on it again. So it spits it out at the bottom of our code chunk. We have our species. We have our average or mean total length for each species, our minimum and our maximum total length. This is a very easy way to get a bunch of summaries on some sort of factor. And this just occurs in a couple lines of code. This summarize doesn't have to be separated among the variables. I just did that to make it look or make it easier to read. It's basically just 3 lines of code. And you have summaries of mean, min, and max total length for every single species in your data set. This group by summarize combination becomes really powerful when you want to summarize your data by multiple factors. So we're going to take our fish data set again, pipe directly from it. We're grouping by here F station, which was the field station number, as well as species. So there are 6 different field stations in this monitoring program. And we want to know, do the total lengths of these fish differ among these field stations and the species? So here we just have the 2 different variables or their factors or characters. And then we can summarize. This is the same code as last time. It's just copied and pasted. Same exact thing. We're rounding the mean to 2 digits. We're calculating the mean of the length. the minimum of the length, and the maximum of the length variables. This time we are not saving it as an object, and we don't have those extra parentheses around it because it'll just spit it out. What this gives us is it breaks it across the field stations. There's 6 field stations, there's 6 species. So we have the first field station first, and it goes through every single species here. So we have mean, min, max. Then it goes through the second field station, and mean, min, and max, and then keep going third, fourth, fifth, and 6 field stations. It gives you all of them broken up. So we went from having just 6 rows here to 36 because it has to do 6 by 6 here. One of the easiest and my favorite way to get number of observations, because things like sample size are really important for biologists or scientists in general, is to use the pipe with group by and summarize. It gives you it counts the data for you, so you don't have to. Essentially, it makes it really easy. So to get a sample size or the number of observations, specify your data set, pipe, group by whatever factor you want. Here we want the number of species or the number of individuals in each species. So we want to group by species, pipe, and we say summarize. And this could be sample size, whatever you want the name to be here. And that equals n, lowercase n, open parenthesis. Don't put anything in those parentheses for this to get sample size. And it comes up with the sample size. And we can see that CNCF, which is channel catfish, has the largest sample size here. BHMW, which is bullhead minnow, has the smallest sample size. So it's a really easy way to get at those numbers. You can do the same thing with count instead of summarize. So you can say fish, pipe, group by species, pipe. So all of this is the same as before. Now we just use count, open parentheses, does the same exact thing. So we'll see that. Run that code, same exact numbers. Either one works for getting sample size. Just choose whichever one you are most familiar with, you feel most comfortable with. So that's an easy way to get summarized there, or to get the sample size with that summarize or count function. So sample size is great. Sometimes we want percents or proportions because then they're comparable across studies, comparable across groups, or anything. And percents tend to make a lot more sense to when we do science communication as well. You can calculate percents or proportions using mutate. Yes, you can do group by with mutate, group by with summarize, group by with count, or a number of different variables and functions here. So we're going to use group by with mutate. And we're going to see what this does specifically. And we're also going to look at using count versus summarize here because they do different things for getting sample size. So if we want to calculate a proportion, and let's say, or percent, and what we want our percent to be right here is just the percent of individuals in each species across all species. So we want to know what percent the bullhead minnow comprise across all of these species, for example. So we first have to calculate sample size. This here is the same exact code we just ran. Data set, pipe, group by species, pipe, use the count function to get sample size. And then we're going to keep piping from there. So, highlighted the wrong stuff. So this is going to give us the same exact information, exactly what we just did. With count, it does this weird thing where you have to ungroup your data first before you can continue manipulating it, or it'll do stuff within that group only. And we'll see what that looks like specifically. And to ungroup your data, you just say ungroup open parentheses. That's all it is. It's just ungroup that. When we look to see what they actually did with the data, it doesn't look like anything. It's just grouping and ungrouping are things in R that we don't actually see. R is grouping them, R is ungrouping them. We don't see that in the table output. Using mutate, we can calculate the percent. To calculate a proportion, it's just n that we calculated. So when you do count, it automatically names that column lowercase n. So that's where that n is coming from. So our proportion equals our sample size n divided by the sum of n. And sum is going to summarize all of the numbers within this n column. That's a proportion, just one sample divided by the total sample size. And then if you want to calculate multiple things and mutate, again, it's just a comma, new column name, percent. And percent's the same thing as a proportion, but you just multiply by 100. So if we run this code, we get our proportions with many decimal places and our percents with many decimal places here. And these should add up to 100. And they do. I'm not going to calculate that, but they do add up to 100 here. If we did not include this ungroup, so let's comment that out and run this code a moment. We get our proportion to be 1 and our percent to be 100 for every single species here, which if we're looking at the sample size across these species, that doesn't make any sense. 291 is not 100% of all of the sample size added together. What R is doing, if you do not ungroup from count, is it's saying it's still thinking it's grouped by species. So it's saying we're performing this mutate to calculate proportion and percent within a species. So we have n, 291, divided by the sum of n. And if we're looking just at bullhead minnow, just within that species, 291 divided by 291 is 1. That's where our proportion comes from. Multiply it by 100 gives us 100%. So it retains the grouping variables. So that is why you have to ungroup if you are wanting to calculate something across all the rows here. You can do this same code. Instead of using count, use summarize like we had earlier. So summarize n equals n here. And you do not have to ungroup with summarize. It will automatically ungroup it for you in R unless you change the default within summarize. So that is a nuance there that I want you to be aware of if you are calculating things past just sample size or something, and you're trying to do some mutations or other summarize functions. Note that count retains groupings, summarize does not retain groupings in your data, so you might get different answers. You might have to use this ungroup function. So one of the handy things with using the pipe and adding like multiple things together and adding qualifiers to mutate is we can apply functions across multiple columns, which is really handy. So like so far we've just been mutating and summarizing things just like 1 or 2 columns, and we have to write them out each time. But what if you wanted to mutate across a lot of columns using like the same variable, like log or something? So if we wanted to log a bunch of variables or multiplying percentages or anything, we can use that with this wrapper called across. So to remind us of what the original data look like here for our fish data set, here we're going in our fish data set, selecting weight and length, just a quick look at those two variables. Weight, we have a 1 in tons of NAs, length we vary across the board here. What if we wanted to create like a length bin column, for example, where we wanted to round these values up to their like nearest or down to their nearest value. So maybe we want length bins of like 50 to 60, 40 to 50, 50 to 60 again, and so forth. So we want like length bins rather than the actual length. We can do, or maybe we want weight bins as well. This might be just easier for data visualization or some sort of statistical analysis. So what we can do is we're going to take our multiple columns within mutate. So specify our data set as fish, pipe, mutate, and it's this wrapper across. So across is just like mutate across columns. So mutate across, use our concatenate function to say multiple columns, weight, and length, separated by comma here, comma, and then this is our function that we want to use mutate for. We want to say we're going to round to the nearest tenths here. We'll see what this looks like, but we just round. We're just trying to round these numbers to get our bins. This is the weird nuance here. This dot X means whatever's in between the C parentheses here. So this dot X is basically a stand-in for columns. And you don't have to specify the column name or anything. And then we're just going to select length and weight to see what they look like. But for this, it's literally just mutate across using concatenate or C, our multiple columns we want. And then the function we want using this tilde, our function name could be mean, standard deviation, whatever you want it to be. A dot X for the functions, and then finish out that function, or dot X for the columns we want, finish out that function. So we see. All right, what this did was round to the nearest tens place. So our weight was 1, it's now 0 because it rounded down. Our length is 50, 40, 60. It's rounding to the nearest tens. And this is going to create some sort of length bin where we're splitting millimeters here, 45 to 55 or the 50 category, 55 to 65 or the 60 category, etc. So this is an easy way to get length bins. You can do means, whatever you want here. If you just want to do something on multiple columns, use this across function if you see fit. One way I used this recently was I needed to take a log of like 15 columns in my data set. So I specified the column names here. You can also use the column numbers and used across to take the log of them. So then it was much easier to do rather than write out everything to run that, like mutate it, like, and write out different mutate functions for all 15 columns. Much easier to use across with that. Here we're going to use across with group by and summarize. So we used it for mutate, now we'll use it with summarize. So let's say we want to get the mean and standard deviation of weight and length using group by and summarize. Here's an easy example. We say fish, data set, or pipe. We're grouping by species because we want the weight and length of these species. We say summarize because we're trying to calculate a summary on it rather than mutate new columns. We say across, this is the same exact thing. Summarize across these columns, length and weight. Make sure that concatenate function is there. So summarize across weight and length. And we want to calculate mean and standard deviation. So instead of doing the like tilde function dot x here, that's just one function. What if we want both? We use list, where mean equals the mean function. Standard deviation equals standard deviation function. You don't have to have parentheses there for those functions. We run that. We get weight underscore mean, weight underscore SD, standard deviation, length underscore mean, length underscore SD. It's going across the two columns of weight and length and doing both the mean function and the standard deviation function, and then naming those new columns it's summarizing the combination of the column name you use, an underscore, and whatever you named it here. So this could be like average, and we'll see that. Now we have length average, weight average. So that's the partial name of the new data column you are making. So that's an easy way. This is just using two columns. Again, you can use infinite number of columns to get like means and standard deviations of these things. So here is another way to do this if we wanted. If we want to get the mean and standard deviation, weight, and length using group by and summarize, instead of this list here, we can do group by species, summarize across these two columns, list, mean equals, then our functions where we use like round here. Because within this list, we don't have the extra qualifiers like removing NAs or anything from those data. It's just literally calculating a mean. And so we have a ton of NAs here for weight average, weight SD, because it's including those NAs in those data. It's not removing them. So to remove them, it is still list, but then you do have to actually explicitly state that function rather than just say mean or standard deviation. These are just the base functions, and you can't add extra column or extra arguments to them. So here it is mean equals, again, that tilde, the mean of dot x, again, a placement for the column names within the C parentheses, comma, NA.rm equals true if we want to remove any NAs. And here we're doing standard deviation as the same thing. SD, our new column, partial name equals tilde, so a function of standard deviation of dot x, again, the placeholder for these column names, comma, na.rm equals true. It's going to now remove NAs, so we actually get the weight, mean, and standard deviation there rather than just those NA values. So it's a little bit more complicated to do. You can't just say mean and SD. You do have to include that function notation there to include things like the extra arguments within any function. You can also complete the above coding with this, but it's just more lines of code. So here we have 3 lines of code to do the multiple rows or multiple columns of calculating weight and, or sorry, mean and length, mean and standard deviation of weight and length. You can do the same thing writing it out long-wise. So here we're creating an object from our fish data set, fish, pipe, group by species, but we have to specify the functions independently. So weight underscore mean equals mean of weight, na.rm equals true. Weight underscore SD equals SD of weight, na.rm equals true. Length mean equals that. Length SD equals that. That is a viable way to do this. However, if you have like 15 columns, this becomes very lengthy code because you have to keep adding this on. And if you are doing multiple functions on each column, that keeps expanding. So just note that You can do it this way, it's a little bit longer, or you can do it this way with the across and listing those functions there. So this code, we've been using this summarize function, and sometimes people get confused with summarize versus mutate, like which one do I use? What we learned last week is that summarize performs summaries on your data, while mutate creates new columns of your data. So they're a little bit different, where summarize isn't keeping all of your data columns and mutate can, and just tack on a new column to it. So this code we could use mutate for, but we have to understand what it's actually doing. It's not creating unique rows of data. It tacks on the information in a new column. So if you have data in a column that's not unique for each row, instead those data are repeated throughout your data set based on your grouping variables when you group by mutate. So for example, here we're grouping by species. So if we use mutate for every individual within that species, for every channel catfish, it's going to have the same variable or the same number within the weight mean column, the weight SD column, the length mean column, and the length SD column. It's just going to be the same value. So summarize makes a little bit more sense with this, but sometimes you might want to mutate that information as well. So you can do the same exact thing. This is the same exact code as this one, but with mutate instead of summarize. Literally same exact code otherwise. We're going to see what this looks like. Cool, it's got all of our data that we had in here already, so it's just tacking on variables at the end of this data set. And we have weight mean, weight SD, length mean, length SD as our new column names, and we can see that these numbers within are repeated throughout. These are all these same species in these first 10 rows. So that mutation of the weight for the mean within a species is going to be the same for every single row that has that species. So that's the nuance there, is it's tacking on data. So those data are going to be repeated with mutate, but it is just creating a summary table with summarize. We only have 6 rows of data here. It's literally just a summary. So that's it for this lesson, is the pipe. We're going to be expanding on the pipe a lot moving forward, and that's mostly what we will be using is piping functions. So really, this is one of the most fundamental aspects of the tidyverse and so helpful for simplifying data so you are not creating just object after object after object with one line of code every time. It is very helpful. So, all right, next time we'll go over more data wrangling.